Alright, so today we're gonna solve problem number 2, which is a sorting an array problem. Basically, we'll be given an array. For example, let's say got 5, 4, 2, 3, 1. This is the array. This is the unsorted array. Basically, we need to sort this array 1, 2, 3, 4, 5 using bubble sort. Now, what is bubble sort? Glad you asked. So I've got an interesting, very interesting flowchart that I have created to explain you how bubble sort works in sorting an array. So basically you're given an array which is this. For example, 5, 1, 4, 2, 8. As you can see, this is an unsorted array. What we can do to basically sort it is, well, you guessed it right, we're gonna use loop. We're gonna loop over array length. So we're gonna loop over this entire array length. And how does that loop would look like, right? So the loop is consist of two loops, which is going to be outer loop and inner loop, but the functioning is a little different. The outer loop basically places one largest element at the end. What I mean is, for example, 8 is at the end, so this is already the largest. Let's consider what's the second largest. It's 5, right? So this outer loop, what it does, it's gonna place this 5 right before 8. Now, this is the function of outer loop, and what the inner loop does is it compare only the unsorted portion. Now the unsorted portion is, for instance, 5, 1. This is the unsorted portion. It's gonna check. It's gonna do this. If left is greater than right, it's going to swap. That's what this is doing. So we got 5 in the left, 1 in the right. 5 is obviously greater than 1, so it's going to swap. So 1 comes here in the left, 5 comes to the right, and this is what the inner loop is doing. Okay, so this is a function. These are the functions of these two loops that we're going to be implementing to solve this problem. And now we also have a little optimization that we're going to do in the code, which is a swap check. What we're going to do, we're going to add the swap check right after inner loop. So as we exit the inner loop, we're going to see, did the inner loop do any swap? If it did, we're going to go to outer loop, and then we're going to continue from there. I'm going to explain it to you while we write the code. You can understand it better. Now, swap check, if the inner loop didn't do any swap check, any swapping, which means swap would be false. In that case, we break out of the loop, and then it goes to outer loop. So here's what it's going to do. So let me explain to you again. we're gonna have two loops, outer and inner. Inner loop is basically doing a swap check. It's basically doing a swap. Swap check is a different thing. Inner loop is doing a swap. It's gonna be swapping two elements based on this logic. If left is greater than right, it's going to do the swap. Okay. Now, little optimization that we are adding is if inner loop did not perform any swap, which means, let's say for example, we have 1 and 4. This is the case where we don't need to do any swap because 1 is already smaller than 4, right? So don't need to do any swap. In that case, swap variable would be false. So if it's false, we're going to break out of the inner loop and quickly go to the outer loop. So this is what the optimization does. It's going to break out of the loop and not going to let the loop run unnecessarily to save time. Let's see how it's going to look. We'll see how it's going to look in the code. So in the code, we're going to first create a function, which would be public static bubble sort. And this function will basically return an array, sorted array, right? This. Now we will define n is the length of the array, and we'll also define a swap check. This is a swap check. This is what we have defined here. It's going to help us break out the loop. This is a little optimization that we are doing in the code. For this is our outer loop. I equals to 0, I less than, and minus 1. So we're basically going to loop over the entire length of the array, and then we're going to have inner loop, which is going to be j equals to 0 goes up to n minus I minus 1. Now let me talk to you a little bit about this condition. Why we have written n minus I minus 1? So basically n is the length of the array, minus I is the outer loop commanding the inner loop that you need to go until this index. Okay, and as the outer loop increases the count of I, the inner loop will have more length to cover. For instance, if it is, for example, if it is 0, right? Initially, if it's 0, what it's going to do is it's n minus 1. I is 0. J going to go from 0 to n minus 0 minus 1, which is the entire length. Okay. So it's going to keep sorting as it's going to so initially what it's going to do is it's going to sort 5 to 4, and this will be then 4 5 2 3 1 initially in the first pass. Okay, And similarly, it's going to go on and do these checks. Basically, based on this, now we need to define this condition. If left is greater than right, then we're going to do the swap. So if of j is greater than nums of j plus 1, let's do the swap. I'm gonna use a temp variable, and then we're gonna have the first number into the temp variable, and the first number, the second number will go to first place, second place will have the temp, and swapped would be true. If we perform the swap, this should be true. And then we go out of this loop if swap is false. No swapped, basically. Then you break out of the loop. Okay. We also need to define swapped here, make it false as a default value. And at the end, we return nums, which will be sorted by now. It should give us this 1, 2, 3, 4, 5 sorted array. Now let's save our function, and we're gonna go to problem to tests, and here we have test and unit test defined to run against our function, to validate our function. It says public static problem should be E, spelling mistake. Should be fine now. Let's look at some of the tests. We got empty array, we should return an empty array. This is our first test. Then we have a single element array, should return the same array. For instance, this is the input 5, and we are expecting the result should be equal to 5. And we have already sorted array. We should return the sorted array, right? Similarly, if you can see here, problem 2. Let me clear the test results. All same elements. This one is a already sorted. This one is a duplicate elements. We got empty array, we got mixed positive negative, we got negative numbers, we got reversed sorted. So we got single element, 2 elements, and unsorted array. So as you can see, we got total 10 and unit test to check against our function. Now I'm gonna run these tests and see what the result results are going to be like. See, let's see, I'm looking at the results, and okay, 10 passed, all 10 tests passed, which means the function, the solution that we implemented here is optimized and efficient, and it works. And this is basically how I approach solving any coding problem, especially for the interview rounds, for, let's say, for QA engineers, automation engineers, or SDETs. If you guys are preparing for any of these profiles, um, so especially for your technical rounds, this approach is definitely going to help you ace the technical round. And I would encourage you to start practicing, and you can also basically follow my series. I'm basically going to be creating 100 coding problems. I'm going to be solving them